Hey everybody, through the course of my career, there have been 4 times when I've seen something and I thought that is going to change the way we do data analysis. And the first time was back in the 80s when I first saw Lotus 123. I think it was running on one of those compact, 30-pound luggables with the monochrome orange screen, for those who remember those. The second time was when I saw R for the first time, and I kind of realized the scope of what it could do, especially as custom packages were developed. The third time was Power BI, when I just saw the interactive ability, the ability to kind of integrate all your data and analyses in one place, publish out to the web easily. And the fourth time was today, when I saw Claude 3.7 Sonnet, and the capabilities this has in terms of interactive data analysis, I think is pretty remarkable, and I think it's gonna really be the direction that data analysis heads from this point forward. A couple of days ago, I posted about this AnyFlights tool. It's an R package you can create great practice data sets, real world, that you can actually draw really interesting findings and insights and recommendations from. So what I did is I created a data set of just 1 month's data from Charlottesville Albemarle Airport. It's a regional airport I used to fly out of a lot. And so what I want to do is actually take that real world data and run it through the type of interactive analyses I could see us all doing with a program like Claude, and kind of compare that to what we're currently doing with Power BI in terms of the results it gives and the time it takes. And so what we can do is we can just take, and I just ran that in R script and just blew it out to a simple Excel structure where I just have 4 tables, and I just put each table in a worksheet. We've got a flights table, which is the flights out of the airport that month of March 2023, a table of airlines that fly out, weather data on an hourly basis, and a dates table, Melissa DeCourte's extended date table, which is the one I always use and recommend. So what I want to do is I have eight queries and visuals that I ran through. And I want to run through those with you and just show you what you can do interactively and what Sonnet does with really pretty minimal prompts. I pasted in the first query. So this is basically the Power BI equivalent of the data model diagram. I just want a diagram showing a relationship with the dimension tables of the fact table, Collie style water flow format. And then have the arrows representing the relationships show the connection between the key fields. Okay, and there we go. We could still make some changes in terms of having them come out of the bottom of the table, but I think you get the point. It's done a nice job in terms of flagging the primary and the foreign keys in the dimension and fact tables. So pretty good job here. Let's run the next one. And now I've got some, simple visual that we're starting with. In this case, it's just going to be a bar chart, and let's start this running. We can talk about it. So this is just one on the average number of flights departing the airport on each day of the week. I think that looks great. I mean, that's exactly what we would do in Power BI. Nice data labels, clear, nicely labeled with the source. So that's pretty simple. But let's jump in and do something a little more involved here. And let's take this and let's perform an analysis of variance to look at the average number of flights, whether they differ significantly by day, and if there's a significant difference, perform a full set of pairwise comparisons with an appropriate family correction to determine which days differ significantly from each other. This is something I have done in Power BI, but it requires a lot of R or Python programming. and a pretty deep knowledge of both statistics and the integration capabilities between Power Query and whatever libraries and packages you're using. So let's get this running. And this was probably going to take a bit of time to crank through, because this is a fairly involved statistical calculation, particularly the pairwise, if it finds a significant difference between the days, which I think, based on just looking at this, it probably will. And this, to me, kind of points out another really critical issue, which is the importance of kind of foundational knowledge and an analytical and statistical knowledge, so you know actually what to ask the AI for. The fact that it's doing all of this programming is fantastic, but if you don't know what to ask it for, that's capability that really goes to waste. Okay, here we go. Highly significant difference between the days, strong evidence to reject the null hypothesis, and then it ran the Tukey's post hoc test, which is the correct test to run. Okay, so it really found three groups in the pairwise testing: Tuesday trough, Thursday Friday peak, and a Sunday increase as business travelers return. And that these are significant differences. So let's actually now take and look at this from the standpoint of the month. And so we'll take a look at the flight traffic over the course of the month, creating a line graph showing the number of flights each day, and a second line showing an X day, not an X say, an X day moving average. And this is interesting, because what I'm trying to do here is test its ability to do interactive programming. So the equivalent of say a slicer or a filter. And let's get this one cranking and see how it does in the interactive element. So okay, here we've got the interactive moving average, and this would be something you would normally do in DAX, and then parameterize the DAX, and then add a slider to your visual. Again, pretty fair amount of work here that it's just cranking out in a couple of minutes. Oh, this I think this looks great. Okay, so what we've got here is we've got the actual data, we've got tooltips, we've got an interactive slider. So we can knock that down to 2 days all the way up to a moving average of 14. So this to me is near perfect. Let's take and do another visualization. I wanted to get into kind of top and bottom 5. So let's get this one cranking. And this is just the airlines with the 5 best and worst on time. And so there we've got a clear distinction between the top and bottom 5, and I think that again is a great looking chart that does exactly what we wanted it to do. Okay, so the next thing I want to do is I wanted to explore some complex mapping, and this is the kind of thing in Power BI that you would need, like icon map and then additional geospatial software on top of. So this would be a big one to do. So you've got to show the flight path of all the outgoing flights in the data set, and then what you want to do is you want to create circles that represent the driving distance that could be done locally at each destination location in 2 hours of drive time from the airport. And so this is actually going to require it to go out and get more data in terms of the relative traffic patterns at each of the destination airports, incorporate that in, and then visualize it. And when I've run this before, I've had some problems with the background map portion, but the flight paths it gets exactly right. So we could reprompt this to get the background if it doesn't nail it on the first try. But I think the important thing here is to look at the amount it's doing in the time it's doing and how much effort that saves, and kind of it opens the door to do things you could never do without major effort. Okay, that's pretty good. So clearly there's some weirdness with the underlying base map, but again, the analysis that it did and the size of the relative drive times, pretty impressive, I think. So I've got another more complex one that I wanted to show you. So here we've got a regression analysis of the minutes of delay and departure based on a whole slew of factors: day of the week, time of day, weather, distance of flight. And this is a lot of complex coding of categorical variables. And what I've got it doing here is, in addition to running the regression analysis, I've got creating a table with the coefficients and the other statistical measures and tests. And then I have it creating a residual plot, which will give us an idea of the goodness of fit of the linear regression. And one of the interesting things to notice is I haven't done a single bit of coding yet. And certainly you have to check your work carefully. You want to validate that it's doing everything it's supposed to be doing correctly. But the amount of coding you can now delegate to a program like this is really remarkable. And if you think about this as being just really the first iteration of what this program is going to be, as I say, I think it is a true game changer. Okay, and so here we've got all of our coefficients. It interprets the coefficients. We've got our key statistics, so the observations, R squared adjusted R squared, and we can look at this and say, okay, it's only accounting for a relatively small proportion of the variance. Okay, so from coefficients, precipitation has the strongest effect on delays. That makes sense. Wind speed has a moderate impact, and temperature, with these other things being equal, has a relatively small impact. Again, those are things we would expect. The weekly patterns look like they line up with our previous analysis. The time of day makes a lot of sense because evening flights are going to kind of have the accrual of earlier delays impacting them. And distance, longer flights show significantly greater tendency for increased delay. That makes sense. Okay, so that kind of shows what you can do in terms of more complex analyses. And then finally what I wanted to show was a matrix. Okay, and there we got a good looking chart. Let's see how it does when we switch to the heat map. Okay, that's solid. It clearly shows the relative crowding patterns in terms of times of day and weeks and days of the week that are heavier. Got our key findings here. And so this is really just a preview, kind of a very early cut. But I think this, as I say, if you think of what this is going to be and what it already is, I find this remarkable. Just that you can generate this so quickly. I mean, we've got a elapsed time of 40 minutes that we've been doing this, and we've created what would take days in a BI software. And so be interested to get your reaction on that. I'll be playing around a lot more with this, but I wanted to give kind of this initial view and see if you have the same reaction to it that I do. So let me know in the comments. As always, thanks for watching, and I'll see you in the next video.